The following content has been provided by RWTH Aachen University.
Now, as we talk about especially sequential interactions, one notation that you've all seen a lot in computer science, of course, comes to the front, and that's graphs. State transition networks, to be more precise, or automata, finite state machines, all the same thing here. State transition networks are probably the most common tool to specify dialogues, and they're a very established format that's been around since the 1960s. We see an example here that shows that these things consist of states, which are usually the moments or the periods of time where the system is waiting for some user action. And the transitions, the arcs between states, are triggered by a user action usually, like selecting something or clicking something, and a system response that is associated with that, like drawing a circle or something. So this nicely describes a sequence of user actions and system responses. One thing just to be aware of right now is what happens inside a state. What happens while the system is inside a state? Yeah?
Waits for user interaction?
And essentially nothing interesting happens, right? The system is sitting there twiddling its thumbs. At least on our level of analysis, right? The system is waiting for a user response, user input for something, or maybe an external event, like, I don't know, phone call comes in or something, right? Something external, or file has been saved or something. But on our level of analysis, the system doesn't really do anything while it's inside a state. That's important to remember. Now, that doesn't mean that nothing is going on at all. On lower levels of analysis, a lot of things might be happening. For example, the system might be tracking the user's mouse cursor across a screen or something, but not at our level of analysis where we only wait for the next click, for example. This system here, what do you think this is describing? This little state transition network. Mm-hmm.
Yeah, it's describing an application where you can draw a circle or draw a line.
Yep, simple graphics tool, right? So it's an extension of our earlier example with the regular expression. Where here you click first, you select the line command, then you click first to start creating a polyline. It creates a rubber band. You can click more points and create more polyline segments, and you double click, that draws the last line, and then it's done, and this sequence is completed. So the option here is to create a circle. We'll get to this example in some more detail in a few minutes. I want to show you another example taken from a system we built many years ago. I was still a PhD student at the time, and we created this exhibit that lets you conduct an orchestra in Vienna. And I'm going to quickly show you the video so you see how the system works. And then we're going to look at the interface specification we wrote as part of that project. So this will just be a short video on the project here.
The House of Music Vienna is a museum documenting the city's rich musical past, present and future. It is located in the heart of Vienna, Austria's capital. Its third floor contains two exhibits designed by our research group. One of them is Personal Orchestra. This system lets you conduct the famous Vienna Philharmonic. Entering this room, you find yourself in an environment reminiscent of a classical concert hall. On a large video projection, you can see and hear the orchestra rehearsing. Reading the one-sentence instruction on the screen, you walk up to the conductor's podium, pick up the baton, and press the button on it. This baton is all you need to use this exhibit. Moving it up and down and pressing the button lets you select your language. The next screen explains how to conduct and lets you select a piece. We will choose the Anna polka. Now the orchestra waits until you start to conduct. The size of your conducting gestures determines the volume of the orchestra. Conducting towards individual instrument sections raises them above the rest of the orchestra. But best of all, the orchestra follows the tempo of your conducting, using a special algorithm to change audio and video speed in real time without changing the audio pitch. However, if you conduct too fast or erratically, the orchestra will stop playing and complain.
Ihr Schlagtechnik ist ja völlig unprofessionell. Das geht überhaupt nicht. Das erinnert mich an das ganz alte Sache an Dirigenten, die überhaupt nicht dirigieren konnten.
But if you conduct well enough, you will be rewarded with a big applause and your players raise themselves. After that, you can pick up a certificate at the museum shop to show that you conducted the famous Vienna Philharmonic Orchestra. This way, personal orchestra lets anybody experience what it is like to conduct the Vienna Philharmonic, and that conducting is much more difficult than it seems.
Okay, so that's the exhibit, still up there in Vienna if you'd like to check it out someday. And we fixed a couple of the problems with the conducting in the meantime. We also have a version at the lab if you'd like to play with it. But the point here for us today is how did we specify for our client, for the museum, and also for ourselves when we were going to implement this later, what the interaction looked like. And we did that. Don't try to read this. I'm going to zoom in a second. We did this in the form of an STN. So it starts off, and there are some issues with this STN also, which I realize now with 15 years of hindsight. It starts off with a program start. That's the first thing that happens, the external event. The program starts. And then we show what the system responds to. It shows a rehearsal video loop. So the video of the orchestra rehearsing is looping endlessly. So there's a lot of stuff happening. But on the analysis level of our STN here, it's basically nothing of interest. So we're in this intro loop state where the orchestra rehearsal loop is running. This continues on until one thing happens. So the user picks up the button, the baton, and clicks the button on it. Right? Until that happens, nothing is going to throw the orchestra out of this intro loop. Once that happens, we don't immediately go to the next state. We actually first wait for the video loop to end. And once it's complete, then we get to this intermediate state here where this thing basically ends. Or we could say this is where we are in this state while the video intro loop is ending. Once it's actually over, we then go to the language selection. So here's the case where this is not something that the user triggers, but it's another event that happens at some point. The video loop is over. We then switch to the language selection and are in this language choose wait state, where the user moves up and down, and we wait for a button click. When the button is clicked, that means we've now chosen a language. Then we basically display the current piece selection as a result and are sitting in this next state. This could also become put together into one state, but since we later want to get back to this particular state here, we split it into two. Here the user picks the musical piece they want to play. We again wait for the baton button to be clicked and determine which selection was made, and then we move to the piece chosen. If at any point the user just walks off and stops using the system so that it comes back useful after a while for the next user, we have a timeout that goes back to the intro loop. And you can see that's happening in various other states too. Whenever the user stops interacting with the system completely, we go back to the start screen after a while, so the system resets itself to a usable state for the next visitor. Now, if we go in here, user picked a piece, then if the information page was requested, we show the information page. From that, we get back by a click to the selection screen. If they didn't want to look at the special information page, we just basically wait for the conducting to happen, because now the orchestra is sitting there waiting for you to conduct. You conduct your first beat. We enter the state, and conducting has started. We start the audio and video, and we are now in a continuous state where the piece is being conducted. Again, these could be combined into one, because you can see here's not really a system action in response to entering that state. So that is basically collapsible into one. Now there's two things that can happen. There's a lot of things going on right now. Right? I'm conducting the piece, the orchestra's playing, I'm tracking the movement, all that is going on. But on the analysis level of this FSM, we're not interested in that, right? We're not actually modeling that. We're just sitting in this state here. This only gets left when you either conduct it too fast or too slow, you get the complaint sequence, or when you're done with the piece and then you get congratulations and again move back to the start screen. And you can see here that, for example, design decisions are being built into this thing, right? For example, we said, hey, when the user fails conducting a piece, we're not going to send him back to conduct the same piece again. We're going to send him back to the piece selection screen. So he gets to pick a different piece. Maybe he didn't like that one. Also, this whole design of going back to this idle state after something, after nothing happened for a while, is all part of the interface design of the system.
This content was provided by RWTH Aachen University.